Okay, class. Tonight we're going to be talking about Chapter 6, which is Qualities and Constraints. And this is sort of the softer side of software requirements. It can be a little more harder to define some of these things. And the reason is it's a lot like, let me bring up my cursor here. When we talk about software in respect of constraints and qualities, it's a lot like talking about a person. You've seen it before. You've described a person as he's got great skills, but he's such a jerk. She's a beautiful girl, but there's something else about her that diminishes the first part of the statement. Well, it's a lot like that with software. It's got the functionality we're looking for, but it has poor quality, and maybe not poor quality because it's buggy, but maybe it's just poor quality in some other respects, and we're going to be talking about that. So taking or going to the end of the chapter and kind of bringing this full circle, it's these things that can influence the buy, no buy decision that the ultimate buyer is going to make on your software. So again, it's those things that can add to or diminish from the functionality of the software. So again, what the person does versus a person's character in this case. The functionality of the software versus its quality. We've got a couple examples here that we can look at. Non-functional requirements includes every type of requirement except one, and that is functional. So you can see right away that this opens up a huge bucket of, if it's not functional, then it must go in this bucket. So when we talk about functional requirements, we're talking about these are the things that the business wants. These are the functions of the software. These are the things the software does. But then there's a whole bunch of other stuff that it's kind of assumed, things that are behind the curtain. Maybe the main customer wants one thing, one piece of functionality, but to bring that into fruition, you require a lot of other things that have to happen successfully in the background. So characteristics of non-functional requirements they are typically non-measurable. Now, this piece is quickly going to diminish as we go through a process of breaking down these non-functional requirements. But just at the onset, at the highest level, non-functional requirements are usually non-measurable. They're nebulous, meaning that they're a little wiggly. They're not always clear. You might say, well, what do you mean by that? And they can be assumed. Oftentimes they're spoken in terms of by the way. So I've had this happen before, meeting with a client, and they say, or we go through this process and they tell me all the functionality that they want. And we go through that discovery process, and then at the end, it's almost an after the fact. Oh, by the way, and we need it to be, fill in the blank. Oh, by the way, we need it to be fast, or we need it to be easy to use. So these are some characteristics of non-functional requirements. So an example of what a non-functional requirement would look for is, high availability. Now, this is something that a lot of customers, if they're not used to working in or with software projects, they would just assume that the system is never going to come down. And they don't even think about it because they just assume it's going to be of high quality. But when we talk about high availability, it's important that we ask the right questions and understand that we all have the understanding of what high availability means. So if you take high availability as a quality that we want to have in our software, let's decompose that a little bit. Let's talk about that more. Well, first of all, we mean it survives a natural disaster. Well, that's even still, we've defined it a little bit, but that's still a little bit nebulous. Another one would be survive usage spikes. I think we all understand what that means, but again, it's not quite there. So we can break it down a little bit more. Surviving a natural disaster means we need to have a redundant system. Okay, now you see we've moved from high availability, which is at this point not very measurable and still a little bit nebulous, and now we've defined it as we're going to have a redundant system. So we have our primary system, we have a backup system. That's becoming a little more clear. Next, for surviving usage spikes, we're going to have an additional server. Under the natural disasters, here is the requirement. The system shall have a complete redundant system located no closer than 500 miles away with failover capability in the event of a catastrophic event. Okay, now we're getting into something that starts to make sense. Again, we're addressing the high availability. We're addressing the fact that it can handle a natural disaster, and we're asking for a redundant system, and then here's the requirement that we're going to meet. Under additional or the usage spikes, we have an additional server, and the requirement would read or might read, there are many ways to write it, the system shall have an additional co-located server with load balancing capability to handle usage spikes of 300%. So now we've moved to something that is non-measurable to measurable, something that's moving from nebulous to not so nebulous, something that means a little bit more. Now, by the way, when we start talking about uptime and downtime and this kind of stuff, we talk about 99% of the time, which 99% of the time sounds like, you know, that's a pretty good system, but that still means that if you're expecting to run 24 hours a day, 99% of the time means that it's going to be down about 3.5 days a year, full days, 24-hour days, or, you know, about 7 12-hour days. Is that something that your business can withstand? Usually not. Usually what I've seen when it comes to availability and uptime, I see, you've seen it before, 99.999% of the time. I typically see somewhere around 3 nines, and sometimes it can be 4 nines. It really depends on the system and the need. So just a little caveat there when we do talk about, 99.999% of the time, that actually means something when we're talking about software requirements. And it means something when we talk about the price of the project that we're going to deliver. So what is the difference when we talk about non-functional requirements that are not measurable, they're nebulous, and just working with them until they become measurable and have more clarity to it? What is the difference between a non-functional requirement and a functional requirement? If you can decompose non-functional requirements into measurable ones, do they remain non-functional? That's almost a philosophical question, but it's certainly the direction that you want to go. And the key word here that I want to focus on, you've heard me use it a couple times already, is this word decompose. So decomposing is really the idea of taking a big idea, taking the main idea, and then asking the questions and starting to, if you were to take I guess the word relates to the decomposing of something like flesh or something when it dies, or an organic matter when it dies, is that it goes back to its most basic parts, the most basic atoms. And in this case, that's kind of what we want to do. We take these big ideas and then decompose them into their littlest, most finite parts. And when we do that, then what emerges is something that is measurable, something that has a lot of clarity to it. It's a very important piece of what you have to do, and it is the most essential thing that you probably can do to make sure that you get your requirements right. Make sure you decompose the big things into little things. So, if you're really turning non-functional requirements into a set of requirements that have the same characteristics of functional requirements, then what does it mean to be functional? Well, as I said before, that really is almost a philosophical question, and I think a lot of people can give you different opinions. Certainly, I have an opinion, as so would other professors and other people who are in the industry. I like to just focus on the functional requirements. These are the things that the software does as a function of the software. It's something that the user experiences. It's an interactive point that the user has with the software. Again, a lot of ways to define it. It is philosophical. And what I like about this book is that the author kind of keeps this in mind. He's a good agilist, as I would say. And on page 141, he kind of breaks it down. He says, really, the moral of the story is perhaps that, it doesn't matter what type of what type the requirement is, whether it's functional or not, just that you don't forget to include it. And that's the really big piece is, if it's functional, non-functional, what you label it, that is not nearly as important as whether you include it or not. So that's really the thing you want to do is include it. And, I know that a lot of you come to a class, especially in when we're talking about software development, and you want to know the rules. Well, unfortunately, and I hope I've conveyed this quite often, when it comes to software requirements, there are no hard and fast absolute rules. There are guidelines for how you collect, how you discover requirements for building software. And the most important thing is that you capture them. And I think that's really what he's saying here. The next thing I really love, and this is something that you should remember wherever you go, is there's no point trying to force requirement language on people. So again, if you're talking with a client and they have nothing to do with IT, they're just wanting you to build it and you take care of all the nitty-gritty stuff, there's no point in saying, well, that's a functional requirement or that's a non-functional requirement. We'll come back to that later. In this industry, if you want to be successful, you need to adapt to who your client is. And you fill in the gap. Don't expect them to fill in the gap. And one way we do this is by not forcing the requirement language on our clients. So when is a good time to capture these non-functional requirements? Well, ideally, and ideally is not always going to happen, but ideally you want to capture these in the beginning. Let me get it to advance here. So non-functional requirements should be determined in the beginning because they are found in all functions, even in the ones we don't know about. So just a very basic example, if the client says, we want our graphical user interface, the GUI, we want the GUI to be very intuitive. Well, you don't want to know that halfway through because you may already have some design sessions that have taken place. So you want to know that up front because that's going to influence all of your user interfaces. Now, when I think of that example, I think, well, why wouldn't you make it? Intuitive? Of course, you want to make these things intuitive. I mean, that's just the way I think. But intuitive, when the client says, we need to make this intuitive because our user base has no tolerance for things that are confusing. And that's actually the project I'm working on now. We're building software for the construction industry that's going to be used by architects and architects and builders and contractors and subcontractors, and they don't have most of them don't have a tolerance for things that don't make sense. They're used to working with paper and pencil and wood and material, and not necessarily are well versed in process flows that might be common to other people. So we are trying to build something that is very intuitive for the customer base that is going to be using the product. So in this case, it doesn't just mean let's do it the way we think best. It actually means bringing in a trained expert on user interface and user experience, so that they can build and help us design a very intuitive experience for the client. So that is something we need to know up front. And when someone says, they may come to us and say, well, we need it to be intuitive. The next question out of my mouth would be, well, what do you mean by that? Tell me more. While we're talking about things that need to be done in the beginning, standards should be determined, and these might be standards, coding standards, for example. These any kind of standards that you plan to use, that you plan to implement through the entire project or product. You want these to be determined in the beginning. Constraints should also be discovered, and we're going to go into constraints a little bit more about what they actually look like. But the constraints are non-functional requirements. They really kind of roll up under this first statement here. And don't know why that went back like that. And architectural framework should also be created. So architectural framework is something that absolutely should be captured in the beginning, because it really describes how we're going to build the product. And now it's not necessarily the analyst's responsibility. Actually, it's not the analyst's responsibility for determining the architectural framework, but it does influence the standards that we'll be using, and it will influence some of the qualities and constraints that you'll have to deal with as you're pulling together the non-functional requirements. And in the beginning, what I mean by that is really before coding the functionality. Again, that word ideally you would want it before design, but for the most part you want it before the coding begins. We've answered the question on when do you capture the non-functional requirements, but the next one is, where do you find them? Well, you're going to find them really all over the place, and unfortunately I can't give you a better answer than that. Probably the first place you're going to hear about the non-functional requirements are going to be stakeholder goals. This may be in workshops, this may be in interviews. It probably will show up in the goals. For example, and this is one I hear often, especially when we're trying to bring multiple systems into one system, and that is, it's got to be easier for the customer to use. It's got to be easier for our salespeople to use, that sort of thing. And before I go on, when we get into easier for the customer to use, these kind of nebulous statements, you can't just let it stop there. Maybe in the course of this particular conversation, you may not want to investigate. You find the right time to investigate it, but you can't just say, okay, and a non-functional requirement is it's got to be easier for the customer to use. You really need to dig into that. What does that mean? If they're wanting something that's easier for the customer to use, then what's driving that request? Well, maybe it's that the current system is so difficult to use, and you probably need to dig into identifying what makes it difficult, and go through a session of observing it being used, and then maybe create a process flow, and then pull that process flow in to a workshop with some customers, and then begin to define how that process flow can be improved. Next one, interviews. You'll hear about this, and you may want to ask the question, or when you ask the question, what are some of the things you want to accomplish? Well, coming out of this, you're going to hear functional requirements and non-functional requirements, and your client is not going to know the difference. They're just going to say, they're just going to start rattling off bullets off the top of their head. They may be organized and have it already prepared for you, but you're going to hear the non-functional requirements here as well. The workshops. Now, I think last week I kind of gave you an example of something that we did with a restaurant chain here in Atlanta who was trying to build an automated profit and loss system. And so when we got into this room and started asking questions, got people talking, and I think I told you that we had about 20 of them in a room, and they all had Sharpies and sticky notes, and they would just write things on these sticky notes, and then we would go around and collect them and start categorizing some of the things that they want. Well, they captured this idea of the functionality, and we call these epics, but then they captured these things called themes, and these were really more of the non-functional requirements. So there's that first one, intuitive, faster, efficient, accurate, scalable, easily enhanced. We'll talk more about this one. Empowering, accessible data, easily trained, provide standardization. So these were the things that with every piece of the system that we build, we need to validate that it's going to meet these things right here. Now that can be a tall order, but we need to understand, how do we address this system being more intuitive? What's wrong with the current system now? How do we address making it faster? Again, how do we measure faster? So this would be a question that I would go back to the stakeholder and say, well, when you say it needs to be faster, what does that mean? What is happening now that is slow? Is it processing time, or is it, the number of clicks that you have to go through? Be more descriptive. When you talk about efficiency, what do you mean by that? And you'll probably hear things about dual entries. Accuracy may be something related to the decimal points, or the way information is depicted in a later screen. Scalable. What does this mean? Does this mean that we can support that the system can support multiple users, or that? I mean, it's a big word here, scalable, but it's talking about can the system grow with the organization? That's actually what they meant in this conversation. Easily enhanced. So if we want to add additional functionality, can we do it easily, or is it something that's going to take 6 months every time we want to add something new? So you kind of see what these things mean, and we heard all this stuff. I mean, this is a real life example. We heard all these things, and we didn't ask about them right then. But actually, what we did is we said, okay, who wrote down intuitive? We want to come back and talk to you. You said that as faster. Who is it that's asking for faster? Well, everybody said faster. So. But we did make a point that we've got to go back and we need to address these so that we can identify the non-functional requirements. These, at this point, does not make a non-functional requirement. These are really just high-level thoughts that we will turn into non-functional requirements. All right, other places you'll find non-functional requirements, standards. So, it may be, again, the user doesn't care about a standard. The user just wants it to work. But your architectural framework may say that we need to use particular standards as we develop this. So that becomes a non-functional requirement. Agile feedback. So in Agile, we like to have this, you do about 2 or 3 weeks worth of work, and then you come back and have a feedback session. And that is a feedback session with the customer. So you want to take that feedback, and that's also a place where you're going to find these non-functional requirements. It may be, and I've had customers say this before, is it really going to be this slow? Well, that's not a non-functional requirement, but I guarantee you it will become one. It's going back to what we just saw. It needs to be faster. Well, what do you mean by that? How do you define faster? And then a checklist. Now, we showed you a checklist. Actually, this is straight from your book. Having these checklists will help you identify gaps in your requirements. Now, this particular checklist, a requirements checklist, and we're going to refer to this later on, so kind of make a mental picture of this. This will help you identify what kind of design constraints, any regulations or standards that you need to work with, any human factors, environmental, physical, these development qualities, producibility, flexibility, testability, all these things are things that are very typical areas for non-functional requirements to sit regardless of the project. Now, you may not think about these things, but they're most likely going to be impacting your project. So this will help you kind of start asking those questions and finding out where these gaps are to help you fill the gaps so that you have functioning software that is of good quality. All right, so what do these constraints look like? Now, they are non-functional requirements, but sometimes they will look like functional requirements. We've already been through this. You know that what's most important is that you capture them. But constraints can look like constraints on the design. They can be constraints on the physical piece of it. Now, the book talks about, the book is really about product requirements as opposed to what we're interested in, our software requirements. So when they talk about physical constraints, they may be talking about, actual constraints of the 3D product that a person can, touch or hold. Really, when we talk about physical constraints in software, probably you're going to see that around screen constraints. Certainly if you are talking about a mobile device, you're going to be talking about a very small real estate to work with, as opposed to if you're talking about something that's meant just for your general laptop or PC, the constraints are going to be a little bit different. Constraints can also look like come in the form of regulations and standards, things you have to do or may not do, as opposed to the law. Environmental constraints can also play as in your software requirements, and then human factors. So let's take kind of bring this down another layer and see what these look like individually. So a design constraint might be something like this. A system must be developed using Microsoft .NET framework. Well, that is, if you're familiar with the I guess it's kind of like two rival high schools or rival colleges. Java and .NET are rivals of each other. So if you are someone who is really high-level designer and you want to have the flexibility to do whatever you want, then you're going to want to be designing in Java, or you're going to be designing for Java. However, if you are that Java person and you're told that the system that's going to be built is going to be built in .NET, you're going to feel a little bit constrained. So this can be a constraint. There are other design constraints as well, but this might be an example of one. Physical constraints. Again, like I said, we're talking about the screen. So in this case, a physical constraint on a screen might be the thumbnail, talking about the little iconic picture that is represented. The thumbnail must fit in a space no larger than 300 by 300 dpi. Regulations and standards. The automatic system login will be handled using SAML, which is Security Assertion Markup Language. It's just a particular language which is really intended for dealing with security in between systems. And let me see, another one. Environmental constraints. After the credit check is complete, the system shall create a signal alert no louder than 65 decibels and no softer than 60 decibels. So this is actually a real constraint that I ran into on a project that I was working on. Going back to when I was working for Singular Wireless and we were building a system for the retail stores, the process was that the salesperson would run a credit check for the customer, and that sometimes came back as fast as 20 or 30 seconds, but sometimes that would come back as long as 8, 9, 10 minutes. And during that time, the sales associate would go find something else to do. Sometimes that was help another customer, or it might be start preparing paperwork or grab a phone and start programming it. And what they wanted was an audible sound, an alert that came or that was signaled whenever that credit check came back. So again, you don't often think of the software having environmental influences, talking about environment that we live in, but in this case it certainly can. Also, laptops and screens can have they emit light, and that is something that can also be an environmental constraint. Human factors. A customer can purchase an item with no more than 5 mouse clicks. Again, this comes from a real-life system that I worked with, and it was related to the same system with the environmental constraints, is that we actually counted mouse clicks. And basically what we did is the original system and the processes that we were using, we were bringing 3 systems together, and we kind of went through and said, okay, to activate a phone for a customer, we would actually go through and count the mouse clicks of the multiple systems, and we would say, okay, this is going to take 33 mouse clicks. That was way back when, but we need to bring that down to less than, I don't remember what the number was, I think it was less than 10. Again, just trying to, that's a part of making it easy, efficient, and intuitive. So again, these are human factors that we can consider as constraints. So when you say, and this really does define a constraint, when you say that something has to be done within 5 mouse clicks, that's really going to drive your process, and it's going to drive your design, and that's a constraint that you need to live with, because guess what? If you do it in 6 mouse clicks, you have not met the requirement. That would be logged as a bug. Maybe a low priority bug, however, but nonetheless you haven't met the requirement. All right, so the qualities now relate more to these themes that occur throughout all of the software, whereas the constraints really just focus on things that press against you, things that you have to work with or work around. Now the book does give you a good list of qualities here. I would say it's a pretty exhaustive list. I'm sure you can discover things that are beyond this list, and really, the list can be exhaustive. It can be much larger than what you see here. These are really going to be more of the things you would typically find. So, starting out with the development qualities, some of the things that you're going to see are producibility, and this is related to how easy is it to produce. Now, again, the book talks about how easy is it to produce a product, and they mean more specifically like how tight are you going to make the tolerances. So you think about how easy is it to produce, say, a mouse, a wireless mouse, compared to how easy is it to produce an iPhone. And I know those are not apples to apples, but you can imagine that the tolerance for something like an iPhone versus something like a mouse, the tolerances just in the manufacturing are going to be miles apart. Well, when it comes to software, producibility can relate to actually probably more of this next item here is flexibility, is how easy is it to configure, how easy is it to upgrade, how easy is it to make changes if you need to make changes. The software that or the project I'm currently working on now, this is a big piece of it. This producibility and flexibility, because we are building software. We're building a platform that other developers will build on. So it's a little bit different. We're not building an operating system, but we're building a platform that other developers can build applications to go on top of that platform. So we need to keep in mind that what we're building has to be easy to work with for the sake of building other software. Another development quality is testability. How easy can it be tested? So this is right now what we're dealing with in our product is being able to test things automatically. Instead of doing a manual test, can we test it through automation? Now, this is important to us because it determines how fast we can develop things. If we have to slow down and let things be manually tested, then we cannot develop and we cannot produce this software as fast as we'd like. But if things can be automatically tested and have this automation suite put together, then we can test it faster, therefore we can produce things faster. This is a requirement of the project, is the automation of the testing. Other qualities would be usage qualities. These look like availability. We already talked about the availability of a system. Dependability, how often does it break? And again, you can bring that down to a finite number. You can talk about maintainability. How easy is it to maintain? What's the skill level of a person who has to maintain it? Usability really goes into the intuitive nature of the product. Performance, how fast does the product run, the processing, and when we get into this, there's one element of performance that relates to your computer. There's another piece that relates to how fast it retrieves data. I've been on some projects where we have people who are in place to their total purpose is to improve data retrieval. And so what they do is they go in and they look at the SQL code and the request for data, and they fine tune it. It's performance tuning of the data request of the SQL code, and that's all they do. And they are able to take some of these monstrous requests, a SQL code, a request that might be, if you printed it out on paper, would be a full page in length, and they reduce that to a quarter of the size, and they take something that takes 12 minutes in an enterprise report to run, and it brings it down to inside of a minute. Again, so that is a requirement that you can have, is that performance for the data, not just the performance of the system that it's operating on. Survivability. This probably, I've struggled with identifying how this would apply to software. Now, certainly, availability, like I said, we talk about, can it survive a natural disaster? I would put that under availability, not necessarily survivability. Survivability would be if you drop your iPhone. When I was working in the wireless with Singular Wireless, I know that all the phone companies have a requirement under survivability that says, the phone must be able to survive a number of drops on a concrete floor from a 4-foot distance. So basically, if you're holding a phone and it falls out of your hand on the concrete, it's designed as a requirement, as a quality, is designed to be able to withstand that. Safety, again, not too much, doesn't relate too much to software, except for software you may translate this into privacy. There may be privacy qualities or actually constraints that you have to deal with. Security, same thing. Interoperability. So this is in software. This could relate to being able to work across multiple platforms, being able to take something that's working in one company and be able to take that data and push it into another organization. Program requirements. Again, this is more related to the IT organization. And actually, this is one I probably would argue that it should be a usage quality. But I think the book gives an example of a network simulator shall be provided by the start of a project phase 2. So that's really a project quality, not necessarily a software quality. But again, going back to the acid test of this is, if it's a requirement of the customer, then you need to capture it. All right, so validating your requirements is really, there's a lot of stuff out there, a lot of requirements that, non-functional requirements, constraints, and qualities that your customer is going to want. And you have to be careful about pressing your customer for, tell me more about all this behind the scenes stuff, because what you want are relevant requirements that really deal with the problem at hand, not just stuff that needs to be thrown in there because someone feels like it needs to be thrown in there because they were asked a question. So validating your requirements is something you absolutely have to do. You've got to bring this full circle. So how do you do that? And the book gives a good list. First, it's verifiability, and this is true for all requirements, whether they are functional requirements or non-functional requirements. Are all of the requirements verifiable as written? Meaning, when you read this requirement, can you understand how you're going to measure whether you met that requirement or not? Meaning, did the software meet that requirement or not? Goal satisfaction. So, the whole idea is you've taken a goal from your stakeholder and you've decomposed it. You've broken it down into smaller chunks. So as you break this down, one goal may have 100 requirements that are required to support that goal. Well, if you code all 100 requirements, does it meet the goal? And it's kind of hard to see. Once you decompose this, you need to understand, is it going to meet the goal? And this may not be something that you alone can address. You may need to bring this back to the architect. You may need to bring it back to other business analysts that are working on the project, or take it back to the stakeholder. You've got to make sure you understand, does this set of requirements meet the goal? Checklist completeness. So I told you, to remember this checklist. We're going to talk about it later. So there are checklists that can help you identify whether or not you've targeted the right non-functional requirements. And just going through and understanding, did you address the availability qualities, the maintainability qualities? Did you deal with the producibility? Did you deal with the constraints that were necessary? So again, these checklists can kind of walk you through that process and help you understand that. Targets predicted to be met. So here's an area, we've talked about it a little bit, and this is related to the goal. So when you know that you're going to be building something, a lot of times, especially if it's kind of new territory, you'll build a model, or you'll build you'll do a development spike, or you'll create simulations. So do these models, do these simulations, do they match up with what you're trying to produce? or at least a piece of what you're trying to produce. Again, so when you build a model, you have a development spike, you need to understand why are we doing this and what does success look like. Qualities and constraints for use cases. Do use cases. Now we talked about use cases 2 weeks ago, it's chapter 5. A lot of times use cases have qualities and constraints specific for that use case. So as you're trying to validate, go through a use case and specifically look for, okay, what are the qualities and what are the constraints that I need to be concerned about? They certainly should be in there, at least a few. If there are absolutely none, I would be concerned. But go back through and make sure that you have qualities and constraints identified. Okay, that is it for Chapter 6, and I will see you after the break.